Welcome. In this video, we will cover Chapter 18 on drugs. Drugs are defined as any chemical substance that can affect the function of living things. Drugs are often used to relieve pain, treat illness, or improve health and well-being in other ways. Drugs can be obtained from several different sources, including natural sources like plants, microorganisms, marine algae, but they can also be produced in a laboratory by chemists. Drugs can be obtained from plant sources, microorganisms, and marine organisms. These organisms will produce chemicals as part of their natural biology. These chemicals or natural products are often produced in smaller amounts. This creates a limitation because in order to produce enough of the material to use on industrial scale, a significant amount of the plant or organism would need to be harvested. In order to get around this limitation, chemists have developed methods to synthesize many of these drugs. Paul Ehrlich determined that certain drugs are more toxic to disease organisms than to human cells. Since then, over the last 100 years, thousands of drugs have been developed in the laboratory, many of which are more potent than their natural product counterparts. This has led to the current state of modern medicine. The first class of drugs that we'll look at are the NSAIDs. These are the non-steroidal anti-inflammatory drugs, or what we commonly view as over-the-counter pain relievers. These relieve pain and reduce inflammation by blocking the production of prostaglandins. These include drugs like aspirin, ibuprofen, and acetaminophen. You can see the structure of ibuprofen and naproxen on the slide. You'll notice that the atoms of these two molecules are connected in very similar fashions. This is quite common in many different drug families. You'll have a core structure of the drug, and all of the molecules in that family will have a similar core structure with several atoms changed in and out. NSAIDs block the production of prostaglandins, which are responsible for blood clotting. This is the source of their anticoagulant properties, and many adults take a small dose of aspirin to help prevent heart attacks and stroke. Cyclooxygenase catalyzes the production of prostaglandins from arachidonic acid. Two of these types of enzymes are known to exist, one found in the stomach and kidney tissues, and one found in tissues where inflammation occurs. This class of drugs block both of these enzymes. Blocking the COX-1 enzyme can lead to side effects, including excessive bleeding and stomach pain. A similar class of drugs from acetaminophen can help reduce the pain and fever without some of the side effects. This drug is not an anticoagulant, but it acts by blocking the COX-3 enzyme. It can be taken by children and those who are affected by the side effects of aspirin. However, it can cause liver and kidney damage in large overdoses when taken with alcohol. In many drugs, a pain reliever is combined with another drug, for example, caffeine or antihistamines. One of the most common ailments, the common cold, is caused by more than 200 different types of viruses. Since there's such a wide variety of causes, there is no effective cure for this, and the medication that's prescribed is generally used just to treat symptoms. A lot of these cold and allergy medications are cocktails that contain several different drugs in them that will treat a variety of different symptoms. These will include antihistamines with some sort of pain relief, or caffeine. Antihistamines relieve the symptoms of allergies, but can also cause sleepiness. Histamines are released by certain cells when the allergen binds to their surfaces. These will reduce the redness, swelling, and itching, and are often combined with pain relievers in the form of common cold medications, such as Dayquil. Cough suppressants will also contain narcotics such as codeine and dextromorphan, as well as antihistamines. These combinations of drugs have been found effective at reducing some of the effects of a common cold, such as cough. Narcotics are a class of drug that has received a significant amount of attention in the United States. These drugs are both effective and dangerous and highly regulated by the law in the United States. Narcotics are a class of drugs that produce narcosis, which is stupor or general anesthesia, and are painkillers. Opium and morphine are the natural source of narcotics. These come from seeds of the poppy. It contains more than 20 alkaloids, sugars, and resins, including morphine. Codeine is a derivative of morphine, replacing one of the OH hydroxyl groups with a methoxy group. This converts morphine into codeine. Heroin is another derivative that converts both hydroxyl groups of morphine to acetate esters. This makes heroin less polar than morphine and more soluble in fat and brain tissue. All three of these molecules are structurally very similar to each other, but have very different effects. The three natural products that we just discussed have only a small difference in their chemical structure. Chemists have been able to manipulate the chemical structure of many different molecules to form what's called synthetic narcotics. Methadone is one example of a synthetic narcotic that is used to treat heroin addiction. Here are a list of some synthetic narcotics and the equivalent oral dose to 30 milligrams of morphine. Some of these are weaker than morphine, but some of them are much stronger. For example, fentanyl is over 30 times as potent as morphine. Because of this, fentanyl is the drug that has led to a significant number of overdoses over the last decade, as it's used as a substitute for many of these drugs on the street markets. Methadone is used as a substitute for heroin addiction, as it reduces the withdrawal